This video is going to look at data collection and how we make measurements about the world around us. So first of all, when we talk about observations, there's two types of observations that we have. And an observation is just something that can be sensed or measured objectively. So something that we can record and kind of take note of, if you want to think about it that way. This can be both with your senses as a human being or with the senses of a sensor, like a device used to measure something. There's two types. Qualitative observations are non-numerical. Quantitative observations are numerical. So examples of qualitative observations would be something like it is hot, like something is hot, something is cold, something is big, something is small. Right, where we describe it, we are still observing something. We are still stating something that is, true about that, but we're not assigning a value to it. Quantitative observation, on the other hand, assign numbers. So someone is 10 years old. Someone is 15 meters tall. That'd be a really tall person, but you get the idea. We're assigning a number. The water is 15 degrees, that sort of thing. Both have their purpose in science and in physics. Neither is necessarily better. So don't get trapped into thinking, quantitative is better because we can have numbers, or don't get trapped into thinking qualitative is better because it is easier to understand, anything like that. They're both useful. The second thing that we can talk about is inferences. So observations were stuff that we could objectively say, like, this is data that's collected from a specific thing. Inferences are assumptions made about a phenomena, and this is typically based on past experience or understanding. And these are important to distinguish from observations because often they can feel very similar. A classic example that I would give is if I see some water on the table, that's actually an inference, unless I get out a chemistry set and I take measurements to determine that it's water. If I see you walk into the classroom with a bottle full of a clear liquid and you spill some on the table, I am inferring that there is water on the table now, because based on past experience, based on a lot of assumptions, I am guessing that what's in your bottle is water. Now, if I did something that allowed me to determine that that was water, that might be an observation. But that's kind of what we want to distinguish here, is when we took a measurement or when we took data about the situation, were we making a lot of assumptions, or were we just recording a measurement? And again, just like with qualitative and quantitative observations, inferences have their place, but you want to be aware of when you're making inferences. So if there's a problem, or if there's something where things don't match up, you can go back and check, did you infer something that may not in fact be true? And then real briefly, when we're talking about measurements, we'll talk about these in greater detail later. It's important to be aware of both accuracy and precision when we're taking measurements. So accuracy is how close you are to a proper or like the actual value. Precision is how similar multiple measurements are to each other. Excuse me. So, for example, if you're shooting free throws in basketball, accuracy is how close the free throws are to getting in the hoop. Precision is how close multiple shots are to the same point. So maybe, for example, if you throw a bunch of free throws and they all hit the exact same spot on the backboard and bounce off and don't go in the hoop, that would be very precise but not very accurate, because it's not going where it's supposed to, but it is all going to the exact same place. It's generally very hard to have something that is accurate but not precise. But it is possible to have something that's very precise but inaccurate. Usually that represents that we've done something wrong in our setup and we'd like to correct that rather than just having a precise but inaccurate measurement. And so this, like I said, generally pursue precision before accuracy because a proper value isn't always known. But like I said, there can be things that offset us that we'd hopefully correct out that would prevent us from being accurate.